So welcome class, welcome to the Earth Science. Today's topic for our lesson is tectonic plates. As you recall, we have discussing some lessons regarding the Earth has different continental plates that move all the time and determine whether or not volcanoes and earthquakes occur. So as we go, I will do every week, make sure that if you have a question, raise your hand, we'll pause and answer your question, because there is quite a bit of information in this lesson and we'll make sure you capture it. Because at the end of the lesson, I'm going to answer a couple of questions to just make sure that you understood the information. And also, as you already know, we also share this information. If you want to review it at a later time, we do record it and able to also look at the slides online if you like. All right? So with that, I'll get started. So first of all, our objective is basically to introduce the topic of Earth tectonic plates. Along with that, we're going to use an online tool called Google Earth. If you never use that application, it's free. It's online. You can look at any part of the Earth, very close up, places you've never been or places you've been, and you're amazed what they look like way above the Earth. Also, we use another application called Interactive Site Explorer. You'll see what the purpose of that is. And at the end, we'll also recap and review the information we just presented to you. And also show you my contact information in case you have any questions. So with that, I'm going to get started. A couple of objectives to make sure that you stay engaged and focused. If you have any questions, please raise your hand. I'll pause and answer those questions. And let's talk about Earth science. All right. So this part, we're trying to set the stage for you to understand a little bit about how the Earth works. The one thing you need to remember about Earth science is that Earth is dynamic. It never it's always changing. It never stays the same. And it's very, 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 very old. So a lot of the process I'll explain to you, you say, well, I never seen that, and I live in that area. It's because it has taken 4.5 billion years for the Earth to look the way it does. And you see a lot of process, so wow, that's interesting, but I've never seen something like that happen. It just takes a long time for things to happen. One of the key terms, a lot of technical terms in the lesson, so I want to introduce that to you. We'll talk about the crust, which is the top layer of the Earth, just like orange. The top layer is the skin, and that's what the Earth represents. The mantle is the inner side of the Earth. There's something interesting about that. The core is the center of the Earth. It's just like a sphere. And then we have the tectonic plates, which is the surface of the Earth. The one thing you need to remember is that they're always moving, and that's what's causing it for the Earth to be very dynamic. And there's a reason for that, and I'll explain that in a minute. Also, once these things move, there's something called erosion, which breaks down the rocks. Rocks, as you always know, are different types, different mineral, different sizes, densities, and so on. But the things that they never stand still. They're always moving or evolving to something different. Also, these plates, as I mentioned to you, are moving, and the three types of movements: divergent, convergent, and transform. And I'll explain that to you. But these are the terms you got to be familiar with as you proceed with this class. All right. So this is a picture of the Earth. It is very technical. The reason why is because it underlines its interior, which is the surface. It's called the crust. And then inside this red part is called the mantle. And then the middle is called the core. Just three parts to it. It's a lot more complicated than that, but at least if you remember these three things about the Earth, you're way ahead. So we're going to study those three and what causes the Earth to create these called tectonic plates. All right, so here's a cross-section of the Earth. That's the best way to do it. So here you see the crust up on top. Here you see the mantle part here, and you see the core. And you can see the numbers. The numbers are not important. What's important is to understand that the Earth is broken up in at least these three sections. A good example of that is if you cut up any fruit like this. This is a kiwi. Anybody tasted one of these? They're delicious. They're good for you. But if you cut it in half, it looks like this. This was cute. I want to pass it around because you understand this a lot better. I'm going to pass it this way. And this one. And that's exactly what it is. The skin basically represents the crust of the Earth. The green part represents the mantle. And the white part in the middle is the core. Remember, this thing is moving though. So as the core gets heated up, it is very, very hot. It causes everything above it to move. And that's what causes these tectonic plates that we need to become familiar with. Again, we have crust, mantle, and the core. There's obviously in between other layers, but right now we focus on those three. All right, so here is a picture of the tectonic plates. So what is that? Pretty much it's the skin of the Earth. And you said, well, how many other? Could be 2 or 3. No, there's a lot of them. So remember, the egg is the Earth is like an egg, and it basically is constantly tearing itself apart, moving, crushing these plates together, and it causes earthquakes and volcanoes. And it has done so over so many billions of years. Look what it looks like now. This is what scientists have been determined. These little plates there are one unit, but they move, they push, they crash into other plates, and this is what causes the Earth to keep moving. And this is what it looks like. It's like an egg. This is a cooked egg I did this morning. This is my lunch, so please don't break it. And basically, if you look at it closely, you saw these little plates. I crushed it intentionally, and you see within this all these plates. In essence, that's what it is. Because it got so heated up, it cooked, and then I smashed it, and inside you got the squares. Notice that there's no uniformity, there's no circles, it's just random. And that's exactly what it looks like, right? Look at this. Nobody could have predicted this, but in essence, this is what the Earth has been looking like for me. Now, it has not always remained the same. There's always changes. So this can be cut in the middle, it can crush it to the other plate, and create all kinds of havoc. But in essence, that's what we're talking about, tectonic plates. That part of the Earth is called the lithosphere, which is anything made out of rock. And you can see these are the major plates, the African plate, Antarctic plate, and so on, North Pacific, South American, and other smaller plates throughout the world. The reason they're important is because they're crushing against each other, and it causes a lot of activity. And here's a picture of which way they're going. This is what the scientists have determined which direction they're moving. Now, they're not moving very fast, because I told you the Earth is about 4.5 billion years. But they're moving up 1 to 15 centimeters per year. That's very, very slow. Right? But we're talking about humongous continents that are just moving all the time. So when these things move 1 centimeter, you'll feel it. And those are called earthquakes. And sometimes an earthquake comprise something called volcanoes. And you'll see a picture of that in a minute. All right, so we got plates, right? So there's 3 movements to each plate. It could be a divergent plate, or convergent plate, They move toward each other. They have divergent plates, which are far away from each other. And they have transport plates, which basically rub against each other. 3 movements, plates. Convergent move toward each other, collide, divergent away from each other, and then transport, which is equal to crush against each other. I'm not going to show you examples of each one of them. And where on Earth can we find them? You'll be amazed where they are. Here's a better picture. So here's the same movement. Transform, divergent, and convergent. I'll repeat those are important terms. And here's a picture of what this gives rise to. Because in this, I told you, these plate movements create earthquakes and volcanoes, right? So here's a plate that's crushing into something else. It's going deep inside these other plates, which causes a volcano to come up, right? It's because it's pushing it up. And also now this happened underneath the ocean also, so that makes it interesting because it causes other interesting geological features you'll see in a minute. All right, let's talk about divergent plates. Remember, these are plates that are away from each other, You see this example? These divergent plates, there's one in the middle of the ocean called the Atlantic Ridge. I'm going to show you an example of that because it's very interesting. The ocean ridge system went around a planet like the seam or a baseball. Basically, these are the seams on the baseball, and these things hold these together. But because they're tearing it apart, they're always moving. Now I'm going to switch over the screen and show you that on Google Earth. All right, so this is Google Earth. Has anybody seen this before? No. Okay. All right, so I'm going to go to my favorites. I'm going to go to the Atlantic Ridge. Well, first of all, let me show you what this does. I'm able to grab this, move it anywhere I want.
Wow.
Very fast. Can I do this right? There you go. That's 365 days. But I want to go here, at Mid-Atlantic Ridge. That ridge, that's the virgin type plate that I just told you about. It's going to take me there. Look what's going to do. You say, wait a minute, I can't see that. Well, Google has taken pictures of pretty much a lot of stuff throughout the world. Not everything. It's looking at it's at the bottom of the ocean, so obviously I don't have a picture of that. But if I do this, I'm going to show you something very interesting. And we're talking about place and riches and so on. It started making sense once you look at it at different angles. I'm in the middle of the ocean. Somewhere south of Africa, I believe. Sure. I'm looking here. Yep, Liberia, Mauritania, and so on. I think this is an Indian Ocean design. All right. So how do I know it's a plate? How do they find out it's a plate? This is Australia, by the way. Because you see these cuts right here, they find out that these plates are spread away from each other. So this side is moving this way, and that side is going that way. 50 centimeters per year. All right? So that's in the middle of the ocean. So it's happening in the middle of the ocean. It can also happen in the surface, and I'm going to show you that also. That's another example. Let me switch screens. All right, so that's an example of the divergent plate. Now, convergent plates are one-sided colliding with each other, all right? And we have plating. So remember this, you saw that picture in which you have all these tectonic plates throughout the world. There's hundreds of them. Here's another one, but in essence, these are crashing against each other. Now, when they crash, they just collide. Basically, one is stronger than the other, and one goes underneath it, and the other one goes above it. Which one it does, we're not sure. But in essence, it gives rise to volcanoes, earthquakes, all kinds of geological activity, including mountain ranges. A good example of that, by the way, this tectonic plates, when they collide, one of them has to go underneath each other, because if they collide, somebody has to move. And the one that is the weakest, the one that goes underneath it, and the process is called subduction. It has to go underneath the other one. Because it's pushing this down way, the pressure creates rocks to rise, or this thing called lava or magma, and then you get volcanoes there. So when you see volcanoes, this is happening. And there's a couple of places in the world in which this happens all the time. Let me show you an example of that. You switch over to the Earth. Let me show you the. Let's go to the Andes. I'll show you that's a perfect example of a subduction. You'll see. All right, we're going to the Andes. Now everybody know where the Andes are at? South America, somewhere near Chile. So now, look what it did. It's okay with somewhere down here. Yes, it is, but show me something. There it is, Bolivia, Chile, South America. So this part is interesting, but you see this part here? This is where it's happening. This is an interesting, and there's a lot of earthquakes, one of the biggest earthquakes we have in this area. These two plates are colliding to each other. This is called the Nazca plate, and it's called the South American plate. And they start colliding with each other. They're converging, so one is going underneath the other. The Nazca is going underneath the South American plate. So that one's there. I'm going to show you the last one, which is the transform plate. Can you switch over the screen? In the transform plates, basically they're colliding, they're rubbing against each other. So they can spread apart, they can come together, or they can rub against each other. It's called a transfer contact. And it's a perfect, I show you this because we have a perfect example nearby. I'm going to show you on Google Earth, because you'll be surprised where it's at. All right, so we're going to Mount St. Helen, way up here. That's a volcano that erupted back in the 80s. You have a top view. There's the volcano. It's dormant now. It's not active. But what's happening here? I'm gonna move this over. Show you a big picture of what's happening. This other one. Wait a minute. It's big. There you go. There's St. Helen. There's the Pacific Ocean. This Pacific Ocean is going this way, and this part is going north. So it's causing dance to happen. Now, if I go south, I run into California. I'm ready. Sacramento, LA, Bakersfield. Looks familiar? There's Los Angeles. Somewhere along this line, you get a San Andreas Fault. As a matter of fact, you can see the line there. See that line there? That's one plate. This side is one plate, that side is the other plate. And this part is moving north, this part is moving south. So there's one right where it is. So that's why we have so many earthquakes in Manila. They find out the cause of it is because these two plates are constantly moving. All right. Can we switch over to our presentation and then summarize this? All right. I'm going to show you Direct Service Explorer. This is another application that I was referring to. It basically tells you where in the world stuff is happening. All right. So this is going to tell me exactly where all the places are located. It even tells me where the latest earthquakes are happening and the magnitude of those places. So it tells you how much activity is happening. If I do this, look what's going to happen. Here we go. These are all the plates, and even tells me where the volcanoes are at, and also the latest earthquakes and the magnitude. If I were to do this, it will mark, it will put a little icon next to the part in which we have volcanoes and earthquakes in those areas. And also which direction the plates are moving. They're showing to find out that these places move in one direction one year and they might move another direction. They're very slow, but it tells you exactly where it's happening. And then also, it can even show, this can play a movie and it'll show which direction the places are moving. All these are earthquakes that have happened over the last 35 years. You see that? The red ones are the most severe. That tells you that the Earth is not static. It's always changing. It's dynamic. And all these places are moving all the time. This is over the last 25 years. Remember, the Earth is 4.5 billion years. So this stuff is relevant to what we do. So with that, I'm going to switch over to our screen. And so in summary, we have tectonic plates, and some of them key by divergent plates. Basically, they're spreading apart, just like the visual says. Convergent plates, which they're coming together. One of them has to go underneath the other. That's called subduction. Or the transform plates, basically they're rubbing against each other. All right? All right, so now we start with flickers. So this is, I'm going to ask you a question. You're going to look at the card, because on one side it says A, the other side has B, it was C and D. All right? So I'm going to activate the flickers with my phone. And I'm going to ask you a question in a minute. There we go. So I want you to look at the screen. And here's the question. You have as much time as you want. So the question is, what type of plate boundary moves away from each other? Don't reveal it out. You pick it. You either say a divergent plate, a convergent plate, a transform plate, or none of the above. What do you think? A, B, C, or D? So I'm going to scan. Put your card up. All right, scanning. Wait a minute. Don't be shy. It doesn't tell you who answered right or wrong. It just does it. Thank you, sir. I got you. All right, let's go to the next one. What type of plate boundaries move away from each other? Is it A, divergent plates, B, convergent plates, C, transfer plates, or D, none of the above? So away from each other, divergent plates, convergent plates, C, transfer plates, or none of the above. If you're not sure, just pick an answer. Ready?
It's the same question.
Is it?
Yes.
Oh, wait a minute. There you go.
Yes.
What type of plate boundaries move away from each other? Oops. There, that's the word. Toward each other. Got it. Ready? Alright, see you back there. Alright, we're scanning, and it tells me what everybody, it got everybody. Okay, good. 100%. Wow. You're good. You're right. Speed. All right. What type of play boundary moves past each other? Past each other. A, divergent plate. B, convergent plate. C, a transfer plate. Or D, none of the above. Past each other. Ready? Here we go. We're scanning. We're scanning. It's picking it up. All right, we're good. 100%. All right. We're good. Yes, it is the transfer plate. All right. So to review and recap, the Earth's interior contains three parts: at least crust, the mantle, the core. Also, it has tectonic plates, and these could be divergent plates, convergent plates, and transfer plates. All right. I hope it highlights a lot of the information that we will be covering, and also the material that I shared with you gives you a better understanding of the material we're covering. If you have any questions, we can just email me, and also the information that I share with you will be available online for you to view at a later time. Any questions? All right. Thank you so much.